This lesson is 4.4 exponential and log word problems. So those are the four formulas that we're going to be using. You don't need to memorize those. They will be given to you. You do need to know how to use them. The only thing that will be given to you on the test is these. So you do need to know what all the different letters mean on your own. Okay, let's do an example. Number or A, you bought a car for $24,000. The car's value has depreciated by 8.7% each year. How much will your car be worth 11 years from initially buying it? So that makes it exponential decay, and that formula is y equals a1 minus r to the t. And so you bought the car for $24,000. So A is the initial amount, which is $24,000. 1 minus your rate is 8.7%. You need to change that to a decimal point, 8.087. And T is your time, and so it's been 11 years. You can just simply type that in your calculator, and you're going to get 8,818 and 40 cents. So that's how much the car will be worth. Feel free to pause this video at any time to catch up, or you can rewind it as well. All right, next example. In 1910, the population of a city was 120,000. Since then, the population has increased by exactly 1.5% each year. If the population continues to grow at this rate, what will be the population in 2014? So it's increasing, so this is exponential growth. So A equals A1 plus R to the T. So it started off being 120,000 was your initial amount. 1 plus your rate is 1.5%, so that's 0.015. And T, you're going to have to do one step here. It's 2014, but we need to see how many years it's been since 1910. So we're going to subtract that. 2014 minus 1910 gives you 204. So that is your time. All right, when you type that in your calculator, you get 564,481.4, so that'd be 40 cents, and that is your answer. Next one, an island initially had 500 rabbits and is growing each year. After 16 years, there are 45,000 rabbits that inhabit the island. What is the growth rate of the rabbits on the island? So it is growing, so we're going to be using the exponential growth formula. Initially goes right here. This is your initial amount, so 500. 1 plus, do we know the rate? And no, we don't, because it's asking for the rate. We don't know that, so we're going to put an R. T stands for time, so it's been 16 years. And there's one other number that we haven't used yet, and that's 45,000. And that's how many there are after the 16 years. So that actually goes on this side. All right, so here's our equation, and we're trying to get R by itself. So the first thing you do is you divide by 500, which gives you 90. And then to get rid of to the 16th power, you take the 16th root. Take the 16th root. So you hit math on your calculator, go down to the root and do the 16th root of 90. That is 1.32. And your last step is to subtract 1. So you get 0.32 equals R. So your rate is actually 32%. That's your final answer. Once again, pause and rewind if you need to. Next one, Amber has a savings account in which her money is being compounded continuously with a 3% interest rate. After 8 years, Amber's account has a balance of 1,907. What was Amber's initial deposit for the account? All right, please circle compounded continuously. Whenever you see the word continuously, you're using PERT, A equals PE to the RT. Anytime you see the word continuously, you're using PERT. A equals PE to the RT. All right, so Amber's account has a balance of 1,907. That's the final amount. What was the initial deposit? We don't know. So P is our variable in this case. E is going to go in the calculator at some point. R stands for rate, so 3%, 0.03, and your time is 8. All right. So to get P by itself, you just simply divide by E to the 0.03 times 8. And on this one, you get 1,510 cents. So that's how much she initially deposited. Mike decides to invest $400 in an account that has a 6% interest rate. What is the balance in the account after 4 years if the account is being compounded monthly? So compounded monthly is your key word. That means you're using the compounded formula, A equals P 1 plus R over N to the NT. And he's investing 400, so that was his starting amount. 1 plus, the rate is 6%. And N stands for the number of times that it's compounded per year. So if it is monthly, that means it's happening 12 times a year. So N is 12. And then T is right here, 4 years. When you type that in your calculator, you want to use the fraction key I showed you a couple weeks ago. So you would type in 400 parentheses 1 plus, and then here's where you want to use the fraction key. Alpha y equals, enter, 0.06 over 12, parentheses, to the 12 times 4. All right, that gives you $508.20. Is your answer. Okay. All right, what is the balance in the account after 4 years if the account is being compounded continuously? So that's going to change your formula. So that's going to be A equals PE to the RT. So once again, you're still using this top number. $400 is your P. E, your rate is still 6%, and the time is 4 years. So you type that in your calculator. Remember the E button is second divide. And for this one, you get 508.50 cents. All right, and example F. Desmond is investing $800 into an account with a 5% interest rate. How long will it take for the account to be $2,800 if the money is being compounded quarterly? So that means we're using A equals P 1 plus R over N to the NT. So he's investing 800, so that's his starting amount. So that goes in for P. 1 plus. Do we know the rate? Yes, it's 5%, so 0.05. N is the number of times per year that it's compounded. So quarterly means 4 times a year. 4 times. Do we know the time? So if you go back and reread it, no, we don't know the time. But we do know we want there to be $2,800 at the end. All right, so I'm going to rewrite that over here so I have room to work it out. All right, so we are trying to get T by itself. So the first thing you would do is divide by 800, which gives you 3.5. And I would go ahead and type that part in my calculator to make my life simpler. So it gives you 1.0125 to the 4t. Now, t is in the exponent. That's like having x in the exponent. So if t is in the exponent, you got to take the log. So log of 3.5 equals log 1.0125 to the 4t. So the whole purpose of doing that is so you can throw your 4t out front. So log of 3.5 equals 4t log of 1.0125. And to get t by itself, you would divide by log 1.0125. And that gives you 100.85. And the last thing you want to do is divide by 4. So you get 25.21. So t is time, so that's 25.21 years is your answer. All right, double I. How long will it take the account to double if the money isn't compounded continuously? So A equals PE to the RT whenever it says continuously. So we know he's investing 800, so that goes in for P. R is your rate, which is 0.05. We don't know the time. And in this one, we want the amount to double. So 800, when you double it, is 1600. But watch what's going to happen. So the first thing you need to do to get t by itself is divide by 800. Well, when you divide by 800, you get 2. Anytime it says double, you're going to end up with a 2 right here. So you don't even really need to know what the initial amount was. You'll always end up with a 2 right there. E to the 0.05t. T is in the exponent, and you got to get it out. So you're going to ln both sides because it's an E. And then you're going to throw that to the front. So 0.05t ln E. ln 2. ln E cancels, divide by 0.05. And you get 13.86 is your answer. All right, G, a new car was purchased in 1990 for $14,000. 3 years later, the car is valued at $5,600. What is the rate of depreciation? For this one, you're using the exponential decay because it didn't use the word compounded. So that's A equals A, 1 minus R to the T. So when it was new, it was 14,000. So that goes in for your starting value. 1 minus, we don't know the rate. The time is 3 years. And we know that the car ended up being valued at 5,600. So that goes on the left. All right, so we're trying to get R by itself. So draw your line. First thing you do is divide by 14,000, which gives you 0.4. The next thing you need to get rid of is the 3, so you do the cube root. So you hit math, and you get 0.737 equals 1 minus R, and then you subtract 1, which gives you 0.263 negative equals negative R, so the negatives cancel. So R stands for rate, so this is actually 26.3%. All right, last one. There are currently 850 students at a high school, which represents full capacity. The town plans, in addition, to house 400 more students. If the school population grows at 7.8% per year, in how many years will the new addition be full? So it is growing. So that is exponential growth. So we're going to use A equals A, 1 plus R to the T. So there are currently 850 students, so that's your starting amount. 1 plus, the rate is right here, so that would be 0.078. T, does it say anything about how many years? No, that's what it's asking for, how many years, so we don't know, so we put a T. We do know how many students we're going to end up with, so there's currently 850, and we're adding 400. So we're going to end up with 1250. All right, first thing you need to do is divide by 850. That gives you 1.471 equals, I'm going to go ahead and put that together, so it's 1.078 to the t. And t is in the exponent, so you got to take the log. So log of 1.471 equals log of 1.078t, and you throw the t to the front. Throw it to the front. And then the last thing you do is divide. So you do log of 1.471 divided by log of 1.078. And you get t to be 5.13. T stands for time, so that is years. All right, pause, rewind any parts of this video that you are having trouble understanding.